Yes, now we are ready for a good number of problems. And deliberately all the time put headings like this: exercise and problems. Exercise generally will be just a recollection of the formulas and substitution, and that won't be very difficult. But problem is actually a problem. Yes, let us see. But before that, I think I should do something more. I'll come back to these things. This on go. Just a minute. Before that, a mathematical summary will write for the whole lesson. You need to keep reminding me. Summary. It should be there by your side anytime you do problems. This will save you time in referring back by turning the pages. Sorry, mathematical. Mathematical summary means you are expressing the whole ideas in a mathematical form, and in the regular language people call it formulas, if you would like to say. Okay, now I am giving those formulas which are directly useful for problems. You could also write some qualitative statements for the ideas, but now the first is the Coulomb's law, isn't it so? So what should I write? F equals, we should write the most general form, 1 by 4 pi epsilon 0 epsilon r q1 q2 by r square in magnitude form. Keep writing along with me. For some time we'll do this.
Yesterday integrations video was kept, right, sir?
That's over, no?
Integration video, another video based on integration. Right.
You want that to be uploaded? Huh?
It is uploaded, sir.
Yeah.
Yes, sir.
Two videos are there which I've taught for first years. Huh?
Okay, sir.
I'll put them.
Actually, actually for us, in our school, it is integration chapter is there for second year, sir.
Anywhere it will be second year only.
Okay.
But the problem is in physics, you cannot talk anything. If you talk physics without integration, that is compromise. Parashara.
Okay, sir.
Then watch those videos 2 times and tell me. I don't mind giving time. Actually, remember,
okay, sir.
As a teacher, I'm very, very excited and feel very responsible for those students who ask. Do you know that? Though time is actually a problem, but if students ask and improve from that, we feel that, yeah, we can spend our time. So watch them twice. That's a very simplified and useful kind of a discussion for integration. No, if you want even other topics, which I'm uploading anyway for first years, I'll send you also. That's not a big deal. But you need to watch and ask doubts, use it. Right, this is magnitude form. But in vector form, could you tell me how should I write? I should consider the signs of charges. 1 by 4 pi epsilon 0 epsilon r plus q1, if this is 2 plus q1 plus charges, into r cap by mod r square. Is it okay, children? Do you remember this? I want you to say yes, no, like that.
Yes, sir.
Yes, sir.
What bad habits you made? Like somebody is demanding you to speak, you just sit like ghosts on the other side. What is that? So this kind of a thing you'll put. Now, why I talk so much is, I know how it is done generally by 90% of the mediocre teachers. So why I insist upon so much response is, the way it is done is definitely very fundamental, and people don't follow it. They'll just bring it to that what you call sequential logic level. something is written from there, something else is written. So the one step from the other step has become a very bad way of doing things. And if you don't catch the idea now, applying that will be meaningless later. So even before we started doing a problem, we should know the purpose of it, where I'm going to use it. So that's why I want your immediate feedback. Like, say, for example, you are near me and I just pinch you hard here. Will you keep quiet, or somewhere you say, oh, it's hurting? And I'm pinching you so much all the time and it's not hurting you. Rishita? Huh?
It hurts, sir.
Then if it hurts, you should say, ah, right?
Yes,
Sir,
sir.
it hurts, but when teacher does, we will keep silence, sir. We will bear it by because we respect teachers like gods.
No, I did not get you. What are you saying?
I'm saying that teachers are equal to gods, so that if you pinch, we will bear it for long time, sir.
Array, that is bad interpretation of a teacher you are doing. Why will I pinch you? Actually, tell me. Am I
I'm just
getting
saying, sir,
pleasure out of it?
No,
No.
whatever teacher do it for our benefit.
No. What I don't know what you are trying to tell is that we respect teachers. Like if some teachers, for example, unnecessarily shouts at you, you keep quiet. Your parents tell you don't, even if they are wrong, don't worry because they are elders or all that. That respect is different from this. Do you follow? This pinching is
Yes,
happening
sir.
because I want you to wake up from your sleep. So the goal is
Okay, sir.
there. Huh? You, Parashara. What you're
Yes, yes.
talking is the respect. In a similar
Yes,
way,
sir.
when a father shouts at you, also sometimes you tolerate, right?
Yes, sir.
That is tolerating is when you're shouted unnecessarily. Isn't it? Shouted it unnecessarily. Ah, come on, father, all right, let us take it. Even if I am correct, father may be wrong, right, all the time. Let me tolerate, you'll think. I'm not talking about that. I'm actually trying to poke you. Isn't it? I'm just putting one spoke into your skin. Will you say, will you sit quietly? You should not. Huh?
Okay, sir. Okay.
Right. Now, this also can be written as what? 1 by 4 pi epsilon 0 epsilon r plus q1. Tell me, how should I write another way? Tell me now. It is already over, no? You can turn and tell me.
Sir,
Hmm.
K into plus Q1 into Q2 R bar by mod R bar whole cap. Whole.
Yeah. This
Sir.
is what I've already written, Abhinav. Hmm? So this is the magnitude form. This is the vector form in two ways. All right. And why did I say this is general form, children? If you make epsilon r equals 1, it becomes air for air. And epsilon r is defined as what? Epsilon by epsilon 0. That means epsilon should have been there here. In that place, we wrote epsilon 0, epsilon r. This is called relative permittivity. Or in future, we'll also call it as dielectric constant. That's the first formula. The second is this. F resultant is equal to F1 bar plus F2 bar plus F3 bar plus dash dash dash. This is superposition, right? This I'm doing deliberately because this video also will be there. When you want to revise, you can listen to this again, even if you don't want to read a textbook. Anshuman, are you okay today? Anshuman,
Yes, sir. Yes, sir.
your fever has gone down?
Yes, sir.
Hmm?
Yes, sir.
Array, you are all young people. Nothing will happen to you. Hmm?
Yes, sir.
Okay. This we already applied, and I hope you remember this. F resultant equals F1 plus F2 plus F3. All right, children, are you writing? Sai Bharat. Sai Bharat, are you writing? When you are spoken to by calling your name, you need to answer. Right. Okay. Then 3. I mentioned already I'm giving a mathematical summary, so I'm not going to write much English there. E equals F bar by Q naught. The basic definition of E is this. 4. E bar equals K Q by R square R cap. R K Q by R cube into R bar. That is plus Q is there. Field is away from it. K Q by R square. Okay. For a minus Q, it is towards it. Even that is KQ by R square. 5. E resultant is equal to, look, every formula is used, every formula has a set of problems below it. Try to understand. Every group of problems will be connected to one formula like this. E resultant is E1 plus E2 plus E3 plus so on. This is superposition of electric fields. Superposition of electric fields. All right. Then dipole. Dipole moment vector P equals Q L bar. Direction is from minus to plus P vectors. 7. Tau equals P cross E. 8. U equals minus P dot E. Here theta equals 90 degrees. U at 90 degrees is equal to 0. The reference point where we say potential is 0. 9. F bar equals del P dot E. I have given by mistake the general formula, but it's okay. That is nothing but I told you already. Fx equals, for example, F equals P dE by dx. That is force on a dipole. Force on a dipole in a non-uniform magnetic field. In a non-uniform magnetic field. This is a generalized formula. Del, don't worry. I can say that. Do you know this del business? There's an operator. Is a vector operator. People say that is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. Just write it. I'll come back to that later. But what we want is this. What I derived for you is this. F equals P d by dx. Did I derive it, or I've given you directly? Did I derive it? That day I don't know. This is what? In a non-uniform electric field, a dipole experiences both force and torque.
So you derived this, sir.
I derived it?
Yes, sir.
Okay, right. This is 9th one. Are you writing along with me?
Sir,
Are you
it
writing?
is force on a sir.
force on a dipole in a non-uniform magnetic electric field. Here, that is dipole moment into rate of change of electric field with distance. This is dx. Tell me your name and
Sir, completed, sir.
right. Next. Tenth one, is it 10th one? Yeah. Now, E on the axis of a dipole. Tell me the formula. E on the axis of a dipole. No one is telling. That means the formulas also are not becoming all right with you. If I write mod E, KPR by R square minus L square whole square. Huh? Is it
Sir, 2
correct?
kpr.
Yes, 2 kPr. Right. This is on the what? Axis of a dipole. For small dipole, tell me.
2 kp by r cube.
Yes, E equals 2 kp by r cubed. Then 11th, E equals, on the equatorial line, what is the formula? Abhinav. We can refer and tell because I'm giving you a culture of learning, believe me. We discussed everything and we have given examples. We're writing the summary. We'll go for problems. That's how you need to do.
Sir, EB is equal to kp by r square plus L square whole power 3 by 2.
3 by 2. And for a small dipole?
kp by r cube, sir.
Yes. But tell me what's the direction of E here? This is the most important point here.
Sir, parallel
to
minus q
axis
axis
and on the side of minus. Okay. Right. 12th. In general, at a general point, for a small dipole, that is when L is less than R. So tell me the formula, Abhinav. E equals, Abhinav.
Sir.
Tell me.
Sir, resultant.
Huh?
Kp
by Kp by
r cube root of 3 cos square theta plus 1.
1. And there is a formula for direction.
Tan alpha is equal to tan theta by 2.
And what is the shape of this whole thing? Minus here, plus there. This is theta. At this point, we are finding out E. So this is theta, I should know. Can you continue?
Yes. Yes.
Yes.
Here in the formula, E equal to Kp by R cube into root of 3 cos square theta plus 1, sir, it is.
Yeah.
Yes.
That's all. It's there already we derived, but you.
Yes, sir.
What's the
Yes,
name?
sir. While writing a small confusion.
What's the name? You got long name. Devachit Parashar. Okay, come on. This is it. Right. Now, I'll continue, children. Huh?
Completed, sir.
Okay. 13th. Now, for any continuous charge distribution, E bar equals integral dE bar, which is k into integral dq by r square r cap. Then I'll keep giving figures here. Line charge finite. This is theta naught. This is theta naught. This is lambda. E will be in this direction only. Do you follow? Charge density is lambda. So E equals how much, children? 2k lambda by y sine theta naught. If I remember correctly, you have to see and tell me. How am I going to explain it? I'll deliberately may write sometimes wrong. That's what I mean by poking and pinching. Is that correct? I'll wait. I'm not in a hurry. I am not in a hurry.
Sir.
Is it correct?
Yes, sir.
And then 15th. Now, infinitely long. This is y. This is y like this. Both theta naught minus theta naught is 90 here, plus theta naught is 90. So E will be what? 2k lambda by y. That is lambda by 2 pi epsilon 0 y, because k equals 1 by 4 pi epsilon 0. Is it correct? I want you to refer, children. Rishita. Rishita, tell me. Are you there, Rishita?
Hello, sir. Can you hear me?
I can.
Sir, my microphone is not working properly, sir, today.
Why? What are you doing to it? Are you chewing it in the middle?
No, sir. Actually, yesterday it fell in water, so it was raining now.
Something like that. Is the formula correct? Right. Next one. You can call it semi-finite. One side it is infinite here. If this is a positively charged thing, this has an x component, y component, each becoming k lambda by y, if I remember correctly. Refer back and tell me there. It may be wrong. So the total will be root 2 k lambda by y. Tell me. They're all questions and problems only. Come on, the future builders of India. Tell me.
Sir, that's correct.
Why am I saying future builders of India? You're going to become BTechs, BEs, right? If your bases are not right and you build a bridge, that will collapse. Okay, can I continue then? Right. Are you writing?
Yes, sir.
So this should be in the mind all the time. You do not have to do this because I'm going to apply these things and make it to a problem. Do you know that? So you need to be careful. In fact, when you do, you can actually have one separate 2 sheets of paper and write all these formulas and put by your side and start doing questions and keep referring back like this and do it. That is how you really are going to improve your capacity for problem solving. Now, can I continue? Can I go to the next slide?
Yes, sir.
From 16, 17. Have a finite line charge like this, lambda, but at this point, this is y, this is theta 1, this is theta 2. Even here, you'll think that field has both Ex and Ey components, and the total E will be how much, children? Can you tell me? Total E will be how much?
Sir, 2k lambda by y sine of theta 1 plus theta 2 by 2.
Yes, 2k lambda by y sine of theta 1 plus theta 2 by 2, which actually is the sum of Ex and Ey. Okay. Then 18, I'll add a few more things, which I did like problems because you can use them directly. If this is theta naught, if this is theta naught, and the radius is r, lambda is the charge density. What is E at the center? O. Tell me. Refer back and tell me. I'll wait.
Sir, 2k lambda by r.
2k lambda by r, no. Sine theta naught. Next. If theta naught is 90, it is 2k lambda by r. Vishra,
I thought it was a semicircle.
how can it be semicircular and how can I put it as theta naught? And deliberately I extended dotted lines like that. It's an arc. Huh? I agree.
Yes, sir.
You may think semicircle. But then why will I put theta naught here as the angles? I'll put them 90, isn't it? Huh?
Yes,
This is
sir.
arc. And what is the direction of field here, children? Still not into mode of physics. Actually, yeah, there are not many people. So, what is there in your minds, in your hearts, you tell me, when you do physics or when you prepare for exams? You got some private thoughts, right, which you wouldn't tell your parents also. Because many times I have seen somebody will be doing it half willingly. Somebody, doesn't understand but pretends to understand. And somebody thinks, what is all this? I'm not interested in this. I want to become a fashion designer, but parents are forcing me for IIT. So, because I see a very, very big gap in the whole learning. Okay. Then after this, I've taken care of most of everything there. Yeah. Now, for a ring, charge ring plus Q and R at a distance X, children tell me what is E. And if it is plus charge, E will be away. E will be away. And that E's magnitude is, tell me children, 1 by 4 pi epsilon 0. Tell me, I forgot.
Qx by
Qx by
x square plus r square all power 3 by 2.
R power 3 by 2.
Three.
So this will be the This will serve the purpose of all the ring problems. Remember. 20th disk of charge at a distance x. Tell me this sigma by 2 epsilon 0 1 minus, maybe I'm writing wrong. I'm writing from memory. I may be wrong. Is that the formula? Refer back. Yesterday only we did, right?
Sir, you wrote 2 pi epsilon 0.
Yesterday? No?
Yes, sir. It is 2 pi epsilon 0.
No, waiting. Just look, pi gets cancelled there. If I remember, I've written it like this. 2k lambda, 2k sigma pi, I think I wrote like this, into 1 minus x by this one. So in which case, 2 into 1 by 4 pi epsilon 0 sigma into pi, I would have written. So pi goes, 2 goes, sigma by 2 epsilon 0 will be there. That's what the calculation I did. So it is sigma by 2 epsilon 0 into 1 minus x by root of x square plus r square.
Yes, sir.
So that is the formula. Now, I'll continue with this 20th for a while. After that, we'll come back to questions. In fact, I want you to study them. If you're serious, if you're serious, listen to me. I told you to write on 2 pages, but how will you write? Not copying like this. Memorize it, and then write. Follow this for some time. That will change your whole game for even other subjects. I was telling you, learn how to learn. This is important. Now, I'll just take this equation and explain it further. So you have a charged disk like this. We were writing the formula at a distance x as E equals sigma by 2 epsilon 0 into 1 minus x by root of x square plus r square. If you're really serious, just talk to me while I'm doing it. We'll consider special cases. Case 1. X is larger than R. Intuitively speaking, if X is very large compared to R, the disk can be thought of as a point charge. So the formula I should probably get will be KQ by X square. Are you okay with my statement? If you're okay, just repeat it up now. For a disk, which is going to be here, for example, I'm asking to calculate E here. So this is almost like a point charge for large distance. This R is too small compared to this X. So like it becomes like a lump of charge here, Q, and KQ by R square. Which formula KQ by R square? This one. So I should be able to guess that when X is very large, it should reduce the formula of a point charge. Now let us check mathematically. Now when I'm talking like this, I'm worried actually whether you're catching or not, Rishita. I'm talking physics and ideas. Mass is the expression. Mass is
Yes,
only,
sir.
there is some meaning behind it. Okay. Now, how to check it mathematically? Look, can you anybody tell me as to how I might try? Hmm? E equals sigma by 2 epsilon 0 into what would I do when x is less than greater than r? I should be able to ignore r. Will I ignore like this? R is ignored, for example. X by x1, 0, can I say? I cannot. I'll tell you what I will do. 1 minus 1 by root of 1 plus r square by x square. I'll do. You know what I did? Do you know what I've done here? The maths part. Hello.
Yes, sir.
What did I do?
So if we simplify that, we'll get x by root over x square plus r square only,
You're
sir.
going backwards. Not a bad thing. I can say that I divided the numerator and denominator by x. I divided the numerator by x, denominator by x. If I divide this denominator by x, x goes inside, x squared becomes, so 1 plus r square by x square. 2 pi epsilon 0 into 1 minus, I'll write it as 1 by r square by x square to the power minus half. That will be by binomial approximation 1 minus, 1 plus x to the power minus half. Do you know how to write this expansion? You don't know, I'll write it for you. There are many terms there. It will be 1 minus, tell me. 1 minus, what series is this called? No idea? Can you refer in Google and tell me? This is math student's job. Becomes second term, I remember. Third term, factorial, like that it comes. So it becomes now like this. 1 minus r square by 2x square plus dash 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 like that. Since x is larger than r, the higher order terms will be neglected. So I'll be left with sigma by 2 epsilon 0 into 1 minus 1 plus r square by 2x square. This will be cancelling. Sigma will be written as q by pi r square, the charge density, into 2 epsilon 0 into r square by 2x square. So it will be 1 by 4 pi epsilon 0 q by x square, which is a point charge formula.
Sir,
Mm.
here the disk becomes point charge, no, sir?
This looks like a point charge. Don't becomes a point charge, you say.
Yes, sir.
Huh? This looks like a point charge for all that external points, large distance points. Tell me. At least, okay, you did not follow in the beginning while I was doing. Now you need to check and follow it. This should become a part of your brain. Do you know?
Sir.
Now, this is what I mean by when something is pinching, you don't express. That is not a good idea. Did any one of you go to a dentist anytime for a root canal treatment by chance?
Sir, my parents are dentists, sir.
Then you know very well. Who? Parashara. You tell your father I told this story. I don't know how is it happening now, but in the root canal treatment, what do? They keep doing that thing, no? Put a needle or something and then keep on
Drilling.
drilling. Not it's not drilling actually. Let's call it drilling.
Leaving.
Okay. So I went long ago. I don't remember, some 25 years ago. I went to a doctor, dentist. So generally, I have a habit of, like you tell, even if I got a pain, I wouldn't express it. So he was drilling. Somewhere he drilled it so much. I said, "Oh, like that." Then he was telling me, "What is this? You are a teacher, and don't you know this?" He said, "What? If you don't say it is hurting you, I'll go on drilling." He said, "Why are you tolerating?" He asked me. That I remember today, and that's what example I keep giving you people. Huh? Tell me, Parashara. Tell your father this about this.
Okay, sir.
If somebody is drilling for root canal treatment, somewhere you should say, "Sir, I'm having pain." Then they will stop. Probably from that time, this time things have improved in a big way in the dentistry business, but still the same idea. Do you really follow this? I'm drilling it too much here. Hmm? I told you to look for this series. You need not, but this is finally for a large distance. It looks like a fine charge. Rishita, can I continue for the next slide?
Yes, sir.
Hmm. Are you writing it?
Yes, sir, I'm writing.
Right.
Your computers are writing.
Right. Okay, then I'll go to the next one. At least this you try to participate and tell me. The same disk thing once again. This is going to the most important formula for future. Now, this is X we set. And we formula is, tell me once again, E equals how much? E equals how much? One is telling me.
Sigma by 2 epsilon of 1
Uh,
minus x by root over x square plus r square.
that is good. And then, now I'll give you one more case. X is tending to 0. That E will be sigma by 2 epsilon 0. You ask a question. Now I drill a little extra. If you're having pain, you tell me. I'll tell you. Now, this is, now when X is tending to 0, I can also say implies R is tending to infinity. Therefore, for infinite uh, sheet of charge, I can say sheet of charge E equals sigma by 2 epsilon 0, which is independent of the distance from it. Come on. Now it is for you. I've presented something idea based. You accept it without questioning, like who was telling? Parashara only was telling. So teachers know, so we need to listen to them, whatever they say. Don't listen to teachers. Nowadays, you trouble teachers. That's the best thing you can do. in subject, of course. So, Nishita dear, tell me.
Yes, sir.
Now,
Uh,
what you mean to say x is tending to 0 is like this. You go and put your eye here. The disk looks very large. That's what you mean by R becoming infinite.
infinity.
That means, practically speaking, if we had a layer of charge like this, I'll put it in, try to put it in 3D. Like it extends all sides. So anywhere for disk, this is infinity, children. It is going that way large, this way large, everywhere. Do you follow? An infinite sheet
Yes,
of
sir.
charge. The edges are not known. So here it is sigma by 2 epsilon 0 at a point here. Here it is sigma by 2 epsilon 0 because whatever distance you got here, that's very less compared to the infinite dimensions of the disk. I told you it's an important idea for future. We'll be bringing it back again and again, and I'll be applying this in the problems later. No, anyway, yeah, problems will start today. Probably we may not be able to finish, but I want you to start doing problems from here, not from memory. I'll tell you how to improve the application capacity if you talk. And then instead of saying x tend to 0, you should ask me, sir, x tend to 0, x is tending to 0, you said, but x equals 0, you put. What is wrong if I put x equals 0? Should be a question. Naturally, that should come from any student. Tell me, Parasira.
Yes, sir.
X is tending to 0. I said sigma by 2 epsilon 0. That's also equivalent to saying that the field near an infinite sheet of charge is sigma by 2 epsilon 0. Not only this side, even this side. Try to understand. Both sides there will be field. Here also, we did not show it, but this side also the same field will be there. So quick.
Writing completed, sir.
Completed. I'm not worried about completing. I'm asking about the question which I put to you.
Sir, x tends to 0 means x is tending to be 0. Sir. Yes, it
Then
want to
why
be
did I
0.
not say x equals 0? Instead of x equals 0, why should I say x is tending to 0? So finally, one statement, I'll make it here, note. For a single layer of charge, this disk is a single layer of charge. Single layer of charge on either side of it, E equals sigma by 2 epsilon 0 very near to it. This is one statement I would like to make. And second statement I would like to make is R for an infinite sheet of charge, infinite sheet of charge on either side at any distance is sigma by 2 epsilon 0. So that is the summary. And I told you this particular formula. Which formula? Sigma by 2 epsilon 0 is the most important formula for us in future. So the kind of statements I'm making in inverted commas are very, very important. Tell me. Please write it down. I'll immediately show you the application of this. I'll go from the backwards now. I'll go random actually. There's no need of going backwards. 20 formulas are there in your language. But anyway, we start with one problem. I'll do that first and come back. So, are you writing it the way I've written it down here? For a single layer of charge, do you understand the meaning of single layer? Charge like this you are forming, not the double layer like which will happen on a metal. For a metal sheet, if you give charge, it will go to the surface and one layer there, one layer here it forms. But here, disk of charge is actually, you can call it disk of charge or a charge stuck on a non-conducting disk, you can say. For a non-conducting disk, if you put charge on one side, it will remain there, it doesn't go to the other surface. So that's what you mean by one layer of a charge. So if I have one layer of charge, either sides, there is sigma by 2 epsilon 0. You did not ask single layer means I explained it for myself. What can I do? Rishita. You are from DAV Public School. What did you say?
BPDAV, sir.
Huh?
BPDAV. BP in the sense Brahma Prakash DAV.
Yeah, that DRDO there.
It's Midhani, sir. It's under Midhani.
Yeah, Midhani. That Brahma Prakash, the scientist's name, isn't it?
Yes, sir.
Why am I asking schools? Because schools actually lay the culture of learning. Are you okay with the statements I mentioned? The most important slide this is.
Yes, sir.
Parashara. Devarchit.
Yes, sir.
Bharat, Abhinav. And Shuman, of course, was not there yesterday, but all right. Now I'll go back to the problem there. Yeah. E at O. Find E at O. I did not put charge, but the moment I put lambda here, think charge is there and plus charge. If I minus, if it is minus, I'll put minus, right? So, how to do this? Which formula to be applied?
Hello.
Yes. Which formula?
Hello, sir. Are you able to listen me, sir?
I am.
Sir, I was trying to speak from that time, sir.
Now I am hearing you. You ask the children. Isn't it so, children? Hello, others. Hello, what's up? Now this formula has to be applied now. All right. So E for this will be which way? I'll draw it separately here. Little bigger. This, if I draw like this, if this is lambda, this angle is how much? 45. This is 45. Am I right? Huh?
Yes, sir.
And E of this will be this way. So E will be, E1 will be
2k lambda by y.
2k lambda by y sine
45.
45. So 2k lambda by y 1 by root.
Root 2.
Due to this, it is this way. Same value. Due to this, it is this way. Same value. Due to this, it is same value like this. All are equal. So E equals 0. So the formula used is what? I'm talking your language. I will never use this formula word. Used is this one. This is theta naught. This is theta naught. We know it is 2k lambda by y sine theta naught equals c. Now this one, second one, tell me. If you're not telling me now, it means you are not following or you did not even know how to study physics.
Hello, sir.
Yes.
Sir, I didn't understood how you got E0, sir.
Everything is there on the picture, right? Y is same. I did not write y. Y will be some. How much is it? A by 2. But since all were opposite, field of this will be this way. 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 So tell me. Ask a question. Why is this 0 means it is already shown there, no? So what do you mean by E becoming not becoming 0 here?
Sir, understood, sir.
What is that you did not follow previously? What is that you follow now? Because that is surprising me. So,
Sir, actually, internet problems, sir. The video was lagging. So I didn't catch it, so I asked to repeat. That's it, sir. Now I understood, sir.
right. So the second one.
Semicircle.
It's only semicircle.
No, sir.
I'll give R here. There's one semicircle and 2 wires up to infinity lines. So at O I want E. You don't need to do it. I'll show you. But remember, the reason I wrote the formulas there, you should know that, yeah, definitely I'll get from there. Look.
So
Tell me.
it is 1 minute, sir.
There are 3 parts. One semi-finite wire, another semi-finite wire, one semicircle. So E of these things, if you know, which already have been given, at this point, how much is E will know. The formulas are there right in front of you, right? Huh? What's happening to you? Children, great people, tell me. Oh, come on. The minimum thing you should say, sir, I should use 3 formulas. The formulas are already there by your side. I don't know whether to blame you or blame your schools or teachers. I don't know. Now look at this. That is one wire. I'll use another ink for the second one. This is one semicircle. This is another wire. So just tell me the formulas for semicircle. I have given you one thing, not semicircle here. I just, for the sake of remembering, I said if this is theta naught, E will be like this, and 2k lambda by R sine theta naught we told, right? Tell me.
Yes, sir.
2k lambda by r, sir,
For
semicircle.
Yeah, it will be 2k lambda by R this way, right? Because
Yes,
of
sir.
this, because of positive charge away. Now for this, how much? For that, there's one more formula.
Kp by r cube root over 3 cos square theta plus 1.
K lambda by 2L.
Like, look at that. If I have an infinite, this one at this point with a positive charge, this is k lambda by y. This is k lambda by y. Did I tell you? And total is root 2 k lambda by y. Huh? Hello.
Yes, sir.
So this is one wire like this. So how should I put y is here? Of course, r. So how should I write both the components? Tell me. This is k lambda by y. That is r. And the other thing is this one, k lambda by r. Now, because of this, at this point, tell me. If you can tell this, then I'll say that you are all right. So for this, where should I show? This is k lambda by r. This is k lambda by r. So ultimately, E will be 0. Tell me.
Sir,
Hmm.
I didn't got why E is 0, sir. The
Because
three sides it
these,
is equal, but
this is 2k lambda by r. This is k lambda by r plus k lambda by r, 2k lambda by r. They are opposite, cancel.
okay.
Upward
Now
k
I
lambda
got
by
it.
r, flow downward k lambda by r, they cancel. It is visible there. What is that not to understand? Huh?
Now I got it, sir.
All right. I think you're all focusing on the steps than how to set it up, right? Tell me. Why don't you speak to me? Huh? Children?
Sir,
No, no. I really am surprised. Like, what is bothering you people? And you're not revealing your, what you call, approach. Tell me, children. Because this is in front of your eyes, it is visible there. This is 2k lambda by r, this is k lambda by r, k lambda by r means I thought you already followed it. Because I've told you what I minus b, everything of first year also I told you. How to find the net force, net thing, all that, right? Huh? Not speaking. Okay. All right. I've closed it for today, but people did not even tell me whether they followed because I've derived it, discussed it, summarized it, explained
followed,
the
sir.
problem.